We will be writing an equation from a word problem. So our title would be word problem for this linear word problem. And it's what I call Mr. Murphy's word problem. Mr. Murphy is 14 miles away from home. He tricycles home at 4 miles per hour. Write an equation for his situation in slope intercept form. So, off the top of my head, for the first piece, when it says slope intercept form, I'm thinking y equals mx plus b, 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 where m is our slope and b is our y-intercept. And I notice that I'm going to also have to interpret the y-intercept, which when I find my y-intercept, I'll put that in for b. I also have to interpret the x-intercept, and I have to interpret the slope. So I will start by, with my interpreting, to kind of think about, I need to figure out what my x and my y are for my interpreting, which is a little hard right now because it doesn't say exactly what it is up here. So what I'm going to do is I'm going to think about a couple other parts before I move on to that one. I know my y-intercept here is when x equals 0, so I will kind of start that thinking. My x-intercept is when y is 0, and my slope, which is the change in y over the change in x. So notice how I wrote all of this down, thinking about all this before I even got my number. So there's really no other than the zeros right now. I'm going to use that in just a minute. But I know that my slope, when I do my slope and my interpreting slope, I've used my words. So this miles per hour right here, oh, it's 4. That's my slope. So I'm going to put my slope of 4. Oh yeah, remember it's over 1. So we're going to do that. Now I'm going to switch to my labeling pen because miles per hour, I remember that that per is that fraction bar, and it's miles per hour, 1 hour, and there's my label. So my miles is my y. So miles I will put down here now, and the x is hours. So now when I go to those things, and it was a little hidden in my word problem up here, but I could remember how it fit with that slope. So I've got my slope, so I can put that into my equation up here to start writing that, equals y and plus, no, well, plus or minus, I'm not sure. So b is, where do I start? My y-intercept, that's starting, and x is our mile, or no, hours. So we're wanting to know at 0 hours, oh, that's our start. So at 0 hours is our 14 miles. And notice how it's labeled up here already. That 14 miles right here has been already labeled. So 14 is our start. And I need to get my labeling pen out. Miles. Now I'll do the x-intercept in just a minute because I want to think about my equation. There is something different about this word problem that makes it tricky. Because if I look at a table for this, and I look at x and y, starting at 0, I know it's 14. In my equation, if Mr. Murphy tricycles 4 miles an hour in 1 hour, that would be, so 1 more hour, he would tricycle 4 more miles, which would put us at 18 and then 22 for the next. Wait a minute. He's going further away from his house, and it says Mr. Murphy is home from his home. So he wants to bicycle. He tricycles home. So that key word right there is our negative for our slope. So it's a tricky hidden negative in there. So that means that this 4 is not going away from the home. We want it to go closer to the home. So that has to be a negative 4. So we really have to be careful about that. So that makes this 8, 4 minus 4 is 10 miles away. So we want him to be 10 miles away rather than 4. So that means I have to actually go back and change my slope over here. So sometimes we think about problems and we get the numbers down, but then we miss, say, the negative, so we have to go back and make some corrections. So, and I myself do that. So I'm going to make sure it gets in my slope and then also in my word problem. All right, so now I'm going to continue on. So minus 4, just double check that. So when I go up an hour early, Mr. Murphy pedals another hour, he's going to pedal 4 more miles towards home, which is at minus 4. So that would be put him at 6. So now we've got our equation. So we've answered A. We've got the y-intercept, but we do have to interpret that. So I'm going to just interpret get the x-intercept. So now that I have my equation, y equals negative 4x plus 14, I notice that this y is 0. So I'm going to substitute that in for my y and calculate my x-intercept. So I'll write that there so I can show that I'm calculating my x-intercept right here. So we'll subtract 14 from both sides. The x-intercept takes a little bit longer because we're solving an equation rather than just putting 0 in for x. So we'll divide both sides by negative 4 to cancel that multiply by negative 4. And now we will simplify this. So in simplifying, I'm thinking negative divided by a negative is a positive. 2 goes into both 14 and 4. So 2 goes into 4 twice. 2 goes into 14 7 times. And then half of 7 is 3.5. So our x-intercept is 3.5. And here's where it is. Our labels is hours. So hours and miles. So wait, at 0 miles, where would he be at 0 miles? Oh, he's at his home. So I'm going to write that x-intercept now that I'm thinking about it. So and it takes 3.5 hours. So it takes Mr. Murphy 3.5 hours to tricycle home. Now, I'm going to put in home as 0 miles because I want to be very clear that I'm talking about that 0. And home is implied. So if you left it 3 hours to tricycle home, you would be fine because you're talking about that 0 miles. But if you just wrote, it takes Mr. Murphy bicycles 3.5 hours, period, right there, then you wouldn't get the full points because you're only talking about half of the coordinate pair. You need to get that home in there to get that full understanding of your interpreting the x-intercept. So now the y-intercept, I'm going to do my y-intercept right here. And for our y-intercept, that would be 0 hours. And we talked about that 0 hours being 14 miles. So really, I could just talk about that 14 miles. So Mr. Murphy, and here I'm going to use the word starts at 14 miles. And that word starts is that 0. It's the 0 hours because 0 hours is, so you could write it as Mr. Murphy at 0 hours is 14 miles at 0 hours if you'd like. But a lot of times we say the sentence, Mr. Murphy starts, or is at the beginning at 14 miles. So I'm going to put in here 0 hours to be very clear that that word start means 0 hours. So now I'm going to interpret the slope. So our slope is right here. And remember, oh, that was in our equation up here, or our word problem where we got that. And it's that minus, that negative was to the home. So I'm just going to write that sentence again. He, Mr. Murphy, tricycles home. And here I'm going to put the negative at 4 miles per hour. And notice I didn't put the -4, the negative in front of the 4, because the word tricycle home implies that negative. So that's why we don't write the negative in there. Otherwise, it'd be a double negative, which would be positive, and it gets all messy. So, but that's what's difficult about this word problem here is there's a lot of hidden zeros and a lot of hidden negatives that you have to really figure out. But to find those negatives, notice what we did over here is we thought about it as our table right over here and realized, well, Mr. Murphy wasn't going further away from home. He was going closer to home. So that table really helps us figure out the positive and negative of this kind of more tricky problem. Now it's your turn to try.